Right now, there are over 2,000 potentially hazardous asteroids being tracked by NASA, not theoretically dangerous. Officially classified as threats. Most of them will miss us. The math says so. But throughout Earth's entire history, the math has been wrong before. Catastrophically wrong. So here's the question nobody actually prepares for. If an asteroid was confirmed to hit Earth tomorrow, what would actually happen? Not in a movie, not in a simulation. In reality, to real cities, real infrastructure, and real people. The answer is stranger, more terrifying, and more survivable than almost anyone expects. Let's start at the moment of confirmation. Scientists don't find out the day it hits. Detection systems give weeks, sometimes months of warning for larger objects. But for a mid-sized asteroid, large enough to destroy a city but too small to trigger planetary extinction, warning time could be as little as 24 to 72 hours. That window changes everything. The first problem isn't the asteroid, it's the announcement. The moment impact is confirmed publicly, human behavior becomes the first catastrophe. Every highway leading away from major cities gridlocks within hours. Fuel runs out at gas stations before most people understand what's happening. This is documented behavior. Studies on evacuation psychology show that people don't process existential threats rationally. They move, they hoard, they follow crowds without knowing where those crowds are going. If you stay calm in those first hours while everyone else panics, you immediately gain a survival advantage most people around you have already thrown away. Now here's something scientists rarely discuss publicly. Where an asteroid hits matters enormously. An ocean impact generates tsunamis that travel at the speed of a commercial jet, reaching coastlines thousands of miles away within hours. A land impact sends a shockwave outward that can flatten everything within hundreds of miles, followed by a debris cloud that blocks sunlight across an entire hemisphere. The asteroid itself isn't what kills most people. What comes after is. At the moment of impact, energy release depends entirely on size. A 1-kilometer asteroid hits with roughly 1,000,000 times the energy of the Hiroshima bomb, but even something far smaller releases energy equivalent to a nuclear weapon on contact. The fireball reaches temperatures hotter than the surface of the sun. Then comes the shockwave. The shockwave travels outward faster than the speed of sound. If you're near a window, the glass doesn't just break, it accelerates into a room like thousands of tiny blades. More people were injured by windows during the 2013 Chelyabinsk meteor event than from any other cause. A relatively small space rock, and the windows were the deadliest part. Now scale that up. The sky ignites. Rocks and debris the size of cars rain back down from the upper atmosphere, creating secondary fires across an enormous radius. Then the dust begins rising. Depending on impact size, the resulting dust cloud can block incoming sunlight globally for months or years. Temperatures drop, crops fail. The food chain begins collapsing not in years, but within a single growing season. This is what ended the dinosaurs. Not the impact itself, but the perpetual winter that followed. So how do you actually survive this? The answer starts before the impact even happens. If you have any warning at all, even 48 hours, your first priority is not escape. It's depth. Underground is the single most important place to be within the first 24 hours after impact. Basements, subway tunnels, underground parking structures. Any significant depth of Earth between you and the atmosphere above dramatically increases survival odds. Water matters more than food in this phase. Stored, sealed water. Because surface water becomes contaminated almost immediately after a large impact, from particulates, chemical compounds, and in some scenarios, radiation. And here's the detail almost nobody mentions. Communication collapses before the impact does. The electromagnetic effects of a large impact can disable electronics across an entire regional radius before the shockwave even arrives. If you're relying on your phone to coordinate survival plans, you may lose it before you need it most. Write things down. Agree on meeting points in advance. Old technology survives what new technology doesn't. Because once the dust settles above ground, a completely different kind of survival challenge begins. The first week after a major asteroid impact is unlike any survival scenario in this series. It's not about finding water or building shelter, it's about waiting. The surface in the immediate aftermath is genuinely hostile. Superheated air, debris still falling, toxic particulates making every breath outside dangerous without protection. The people who survive the impact phase are the ones who resist the instinct to go outside and see what happened. Stay underground, stay sealed. Wait. By day 3, the immediate physical danger begins dropping, but the sky is wrong. The dust is already spreading. Sunlight that normally reaches the surface is being scattered and blocked by impact ejecta, vaporized rock, and smoke from fires the impact triggered across entire regions. The temperature begins dropping, not dramatically at first, a few degrees, enough to notice, enough to matter for crops already in the ground. By the end of the first week, survival shifts completely away from the impact itself and toward something far more insidious. Food, not immediate hunger, long-term agricultural collapse. A dust veil reducing sunlight by even 20% can collapse crop yields across entire continents within a single growing season. And here's what should genuinely concern you. Global food systems currently carry approximately 90 days of reserves. 90 days. After that, without new crops growing, supply chains fail in sequence, accelerating like dominoes, each falling system pulling the next one down faster. This is where survival shifts from individual decisions to community decisions. Greenhouses become the most valuable structures on Earth almost overnight. Any enclosed growing environment that can simulate missing sunlight keeps food production alive when outdoor farming fails completely. Seeds become more valuable than gold within weeks. Not money, not weapons. Seeds and the knowledge of how to grow in artificial conditions. By month 3, communities that cooperate survive. Communities that compete destroy themselves before any external threat reaches them. But asteroid survival introduces one factor none of the previous episodes touched: international cooperation. Countries with underground seed banks like the Svalbard Global Seed Vault buried deep inside an Arctic mountain become critical lifelines for restoring agriculture after the dust clears. Countries with nuclear power plants unaffected by sunlight loss become energy anchors for rebuilding surrounding regions. The communities that survive longest aren't the most isolated, they're the most connected. By month 6, the dust begins thinning. Partial sunlight returns. This single event, the first day sunlight measurably increases again, becomes the most psychologically important moment in the entire survival timeline. Hope returns before food does, and that sequence matters more than most survival guides acknowledge. Groups with forward momentum, even before material conditions improve, consistently outlast groups in better conditions who lack purpose or direction. By 1 year, the world is rebuilding. Slowly, unevenly, differently in every region. But humanity has survived asteroid impacts before. Not this civilization, but life itself has absorbed catastrophic strikes and rebuilt from almost nothing, repeatedly across billions of years. The difference this time is that we know it's coming. We have warning systems, underground facilities, seed vaults, and accumulated scientific knowledge that no previous extinction event ever had access to. The rock falling from the sky is almost the simple part. The real question isn't whether humanity survives. It's whether you survive the first 72 hours. So tell me, if you had 48 hours warning right now, what would you do first? So, what do you think? Leave your theory below. Subscribe for more impossible questions.